All right, today we're going to be talking about oxidation numbers. So on this paper here, we have the definition of oxidation numbers. So it's going to be a number of electrons that a certain element gains or loses, and that's going to be during ionic bonding. We'll talk about that later. Or they share in covalent bonding. Again, we'll talk about that later. So again, an oxidation number is going to be a number of electrons that an atom loses or gains, for the most part, during bonding. Then we have an ion is going to be a charged atom. So when an atom loses or gains electrons, it's going to be either positively or negatively charged, and we'll talk about that in a minute, due to gaining or losing electrons. All right, so we have family one. Family one is the alkali metals, and you know that from this periodic table that you colored the other day, and we had gone over, and the notes are on the front side of that. And so with the alkali metals, they're all going to lose one electron. All the metals, no matter what metal it is always going to lose electrons. So this first family is going to lose one electron because when you draw it out, it only has one valence electron. So it's going to be easier for that element to just give away its one electron, and then it would have a full shell in the next least shell. When it loses one electron, it's going to have a +1 oxidation number. I know that sounds weird, but when it loses an electron, it is no longer going to have the same number of protons and electrons. Now it's going to have one less electron than it has protons. So that means it's going to have one more proton than it has electrons. So the one more proton kind of wins out, and it's positively charged. Remember, these are the most active metals. They're never alone in nature. Then we go to the next one, the alkaline earth metals. Those have 2 valence electrons, if you remember, and they will lose those 2 valence electrons because remember, all these atoms are trying to make 8 valence electrons total, and with the exception of hydrogen and helium, but they're trying to get 8 valence electrons total. So it's going to be easier for these, since they only have 2 valence electrons, to lose 2 than it would be to try to go out and gain 6 more to make 8 total. They're going to form a +1 oxidation number. This means that after they lose 2 electrons, they're going to have 2 more protons than they have electrons. And these are also active metals, just not as active as the first family. Then we go to the transition metals, which we don't really need to worry about too much because their oxidation number varies, but most of them are either losing 1 electron or losing 2 electrons, and then depending on how many they're losing, they have a positive oxidation number of 1 or 2. Then we move on to the boron family. The boron family, most of them are metals. Down below boron, boron is a metalloid, and we're not really going to worry about boron, but most of them under boron are metals. So they have a +3 oxidation number because they have 3 valence electrons. So again, it's going to be easier for them to get rid of 3 electrons than try to go out and collect 5 more to make the 8. Then we move on to the carbon family. So in the carbon family, we have some metals and some nonmetals. If it's a metal, it's going to lose 4 electrons, +4 oxidation number. If it's a nonmetal, it's going to gain 4 electrons and have a -4 oxidation number. Then we move on to the nitrogen family. The nitrogen family is all nonmetals, and they are going to gain 3 electrons because remember they're family 15, so they have 5 valence electrons. So it's going to be easier for them to go out and get 3 more electrons than it would be to try to give all 5 of theirs away. So they're going to gain 3 electrons. Now they're going to have 3 more negative electrons than they have protons, so that's a -3 oxidation number. Then we have the oxygen family. The oxygen family, again, nonmetals, and they are going to gain 2 electrons to make a total of 8. The 6 plus the 2 makes 8. And they have a -2 oxidation number because when they gain 2 electrons, they're going to have 2 more electrons than they were supposed to have. Then the halogens, group 17, so they have 7 valence electron. They are looking to gain 1 electron to make 8, so they have a -1 oxidation number. Going back to the halogens, they're also active nonmetals, but not as active as the halogens. So the halogens are the most active nonmetals. They're never alone in nature. And yeah. Then we go down to the noble gases. They all have 8 valence electrons with the exception of helium. It only has 2, and remember it's happy with those 2 because it totally fills in the first energy level. They will not be gaining or losing electrons. They have an oxidation number of 0 because they're not gaining or losing. And remember, they're stable. They're unreactive because they're not going to be bonding with anything. A fancy science term is the word inert. And again, they do not bond. Okay, the next thing we're going to do is we're going to take all these oxidation numbers and we're going to place them on our periodic table above our families so that we can use this as a reference. So we would be putting +1 there, +2 there. Let's see, over this family, we're going to put +3. Over this family, we're going to put a +4 if it's a metal, like these down here. And if it's a non-metal, it would be -4. So like carbon would be a -4. Then we go on to this family, and the non-metals in this family would be -3. So put a -3 up there, -2, -1, and 0. And then we will end up using these numbers for some other work that we end up doing. Bye.